Hello again, Algebra 2. Okay, so this is cosine that we're looking at. Again, we need to know our unit circle, and we need to know our coordinates because we talked about how sine is the y, and so cosine is the x. Remember, if this is your angle, opposite, well, that would be the y value, which is sine, right? Opposite over hypotenuse. Hypotenuse is all 1, so that's easy, which means cosine is your x value here. So all of these x values are the values of cosine. And that's really handy because if you have them memorized, then you just know them off the top of your head, which is awesome. So we will start here at the 0. Hopefully you notice that 0 radians has a cosine of 1. So that is the first thing we're going to do. And then I actually want to go in the positive direction first, and we'll come back to the negative. So the next one is pi over 4. Pi over 4 has a cosine of root 2 over 2. And then we are up at the 90-degree angle, which is pi over 2, and that has a cosine of 0. And now we're at root 2 over 2, and then we are at negative root 2 over 2, my bad. And then at negative 1, and then we are down here at negative root 2 over 2, and then we are at 0 again. Then we're at root 2 over 2, positive this time, okay, because that 7 pi over 4 is over here, right? So we are at the positive value, root 2 over 2. And now we're back up here, which is 2 pi, which is also 0 pi. So we're at 1. And then we can recognize that if we're at 9 pi over 4, that means I've gone a full time around and I've gone a little past, what are we at? Root 2 pi over 2. All right, so now let's go in the negative direction. Negative direction. Well, we always start here. That's always our first side, right? And now I'm going down by pi over 4. Well, that puts us at 7 pi over 4. 7 pi over 4 is at root 2 pi. Sorry, root 2 over 2. So many pi's. No pi's there. Then we're way down here at 0. Then we are at negative root 2 pi over 2. And then negative pi would give me negative 1 because I've gone a half circle around. And then I am at negative root 2 pi over 2. And then we are at 0. And then we are at root 2 pi over 2. Then we are at 1. So similar values to sine, different order though, because we are not starting at 0, we are starting at 1. So when I go to graph this, we'll graph it right the first time. I'm going to graph it at 0, 1 here. And then we've got our root 2 pi over 2, so that's in between these, right? So it's in there, and it's a little over a half. And then we're at pi over 2 is 0. And then we're at negative. So again, about halfway, a little over half. And we're at negative 1. And then we're going to be up there. And then we are at 0. That's where I was in my table. And then we are at about here. And then we are at 1 again. And then we are down here. And we can actually infer where we're going to be with this one, right? Even though it's not in our chart, hopefully that we see the pattern. This is back at 0. So when I go to actually graph that, you want to have a smooth curve, rounded. Okay, we don't have anything pointy here. That is the first side. That's the positive side. So now let's go in the other direction. So negative pi over 4, is root 2 over 2, which is about there. And then we are down here, and then we are about here, and negative pi is at negative 1. Ooh, I put that a little low, my bad. And then we're at negative root 2 pi 2 over 2. And then we are at 0, positive root 2 over 2, and then we are at 1. So when I go to graph this, again, hopefully we're noticing some patterns. So let's talk about those patterns, shall we? What are those patterns? Well, let's look at the x-intercepts to start. X-intercepts, where is it across the x-axis? We're just looking between negative 2 pi and 2 pi. That's it, no further. Well, between negative 2 pi and 2 pi, I have an x-intercept here, 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 and here. I'm going to ignore this one because it does not fit my parameters. How many x-intercepts do we have? Well, we have 4 of them. Where do we have them? We have them at x equals negative 3 pi over 2, x equals negative pi over 2, x equals pi over 2, and x equals 3 pi over 2. Okay, so you're probably noticing some patterns. Great, hold on to those. Okay, we're going to come back to it in just a second. Just a second. All right, local maximum values. What is the highest it ever gets? Well, hopefully, I didn't draw that one very well, but hopefully we can see that the local maximum values, and it's in our table, right? The local maximum values are all 1. That's it. They're all 1. Now we have to look at where the x is that local maximum. So that means we're there at negative 2 pi, 0, because that's what's there, right, is 0, and at 2 pi. So these are at x equals negative 2 pi, x equals 0, and x equals 2 pi. All right, local minimum. Where is the smallest? Right here. So the lowest it ever gets is the negative 1, and that happens at negative pi and at pi. So x equals pi, x equals negative pi, or vice versa, either order. Increasing and decreasing intervals. So an increasing interval is when we're going up the roller coaster. Remember, we start from the left and we go to the right. Decreasing is when we're going down. So if I start from negative 2 pi and work my way to the side, I can see that this is actually a decreasing interval. I am starting at the top of my roller coaster. I'm going down. And then I have an increasing interval right here. And now I have a decreasing interval again, as my lead pencil just broke. And then I have another increasing interval right here, and I'm at 2 pi, so we call it good. So when I look at this, my increasing interval is from negative pi to 0. It's negative pi is less than x, which is less than 0. And I have an increasing interval from pi to 3 pi over 2. Okay, decreasing intervals from negative 2 pi to negative pi, and from 0 to pi. Those are my increasing and decreasing intervals. Hopefully you guys are looking at this going, man, Miss Fresh, this just feels so familiar. This feels so familiar. It's like we just did sine again. Okay, I agree with you. It's like that, except we didn't. It's cosine. And hopefully you'll notice that it's like sine was just like off put a little, right? Because normally we start here for sine. Normally that's where our 0, 0 is, right here. So cosine is off by a half a pi, or pi over 2, if that makes sense. So they are really similar, but they're not quite the same. Not quite. All right, characteristics of this function. We know that we have a local max. The local maximum values, there we go, are all 1, right? That's the local maximum. It doesn't go above 1, ever. It's just 1. And then the local minimum values are all negative 1. Right? That's as low as it goes. So that's similar. In fact, it's the same as sine. The next thing we want to think about is how the pattern repeats. Right? So I have this kind of curve. And for this one, it's from like there to there to there, right? The pattern, there we go, pattern repeats. And then our x-intercepts. there is a pattern with them. And honestly, the pattern of this one is just as pretty as sine, because the x-intercepts are at plus or minus 3 pi over 2, plus or minus pi over 2. And it gets really cool as you go further and further on. So we actually saw on our graph that we have another x-intercept right here. So hopefully you can infer that there is another x-intercept at negative 5 pi over 2. So for this guy, it's not even pi's. For this guy, it's all of the odd pi over 2's, right? 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And that pattern keeps going. That's really cool. The end behavior for the graph. Well, just like with sine, this function does not get closer and closer to one number. It doesn't have an asymptote or anything like that. So with this one, the graph oscillates between 1 and negative 1, between y equals 1 and y equals negative 1. Right? That's what it does. It does not approach a single value. And again, this is so cool because it represents things like boats and other things like that. So it's just really neat. All right, I hope that you have enjoyed our sine and cosine journey. I will see you tomorrow.